dispersion. Okay, what is dispersion and which color gets relatively more dispersed. So this is the first question. So before that we have to know what is the meaning of dispersion. So dispersion means it is a process of splitting or separation. Okay, so here dispersion means it is a process of say separation or splitting. So in our case dispersion of light is nothing but, as you know, the white color. Okay, so white color is nothing but mixture of 7 colors. So it is going to have violet, indigo, blue, green, yellow, orange, red. Okay, so it is a process of dispersion means it is a process of dividing the white color into its individual colors. Okay, so that is starting from violet to red color. Okay, in which the red color is going to have wavelength maximum. So the wavelength of red color is maximum when comparing with the violet color. So here the wavelength of violet color, okay, so that is minimum. Okay, at the same time here we are going to discuss about the refractive index. So refractive index means whenever there is a propagation of an optical wave from one medium to another medium, so there is a bending of the optical wave or optical ray. So that will be described by refractive index. So when there is a change in the medium, so the optical light is nothing but the optical wave are going to be bending. Okay, so dispersion means it is a process of separating the white color into its individual colors. So here I am going to take a prism. Okay, so when white light is going to be incident, so white light is nothing but it is a mixture of 7 colors. Okay, so violet, indigo, blue, green, yellow, orange, red. Okay, so if there is no prism, the light will be moving into a straight line. So because of rectilinear property, but there is a change in the medium. So if mu is the refractive index, whenever there is a change in the medium, bending of the optical wave or optical ray is going to be taking place. So ray is going to be bending. But this bending, the refractive index, okay, it depends on the wavelength. It is inversely proportional to the wavelength. Okay, that means here the wavelength for red color. Okay, the wavelength for red color is maximum when comparing with the wavelength of violet color. Okay, so here the refractive index is inversely proportional to lambda means the refractive index corresponding to red color is minimum. Okay, when comparing with the refractive index corresponding to violet color. Okay, that means the refractive index of violet color is maximum, the refractive index for red color is minimum. Okay, so for violet color the refractive index is maximum means the violet color will be bending much more greater when comparing with red color. Okay, so it will be bending much more. So this is nothing but the deviation. Okay, so this is nothing but the deviation for violet color. Okay, so which is going to be bending much more when comparing with the red color. So for red color the refractive index is minimum. Okay, so there is a minimum bending when comparing with violet color. So this is nothing but the minimum bending for red color. So the first part of the question is nothing but what is dispersion. So dispersion is nothing but it is a process of dividing the white color into its constant colors, that is nothing but VSAQ. Then which color gets relatively more dispersed, so that is violet color, because the refractive index of violet color, okay, is maximum, therefore it will be bending maximum. Okay, the dispersion will be maximum. So this is the first question. Then second question, what is define question, why is it necessary? So the second question again, it is going to have two parts. So define modulation. So here the meaning of this term modulation. Okay, modulation means it is a process of changing, alteration. Okay, so modulation means it is a process of changing. So before going to this question, here most commonly two types of words are used in modulation. So one is called as audio frequency signal. Okay, so audio frequency signal. So the examples for audio frequency signals are nothing but it may be a speech, okay, or it may be a song. So this is nothing but audio signal whose frequency will be in the range of 20 Hz to 20 kHz. Okay, so this is the frequency range of audio frequency, okay, which is also called as AF signal. Okay, so AF signal. So because of low frequency, their energy will be minimum. So according to formula E equal to H nu, where nu is the frequency, so frequency is low. Okay, so low frequency means the energy will be low. Okay, so for these signals, okay, nothing but speech or voice, whatever I am going to sing or talking, so that is called as audio signal. So the audio, the frequency of my audio or my voice is low, therefore it is going to have a low energy. So because of low energy, this audio can't travel to a long distance. Okay, so can't travel to longer distances. That means if I want to make a nothing but if I want to give a speech from here, okay, so the person who is sitting at a distance of nearly 100 kilometers, he can't listen my voice because my voice is going to have low frequency, so low energy, therefore my voice can't travel to a longer distance. That's why the person who is sitting at 100 kilometers distance, he can't listen my voice. Okay, so that is called as audio frequency. So audio frequency means it is low frequency signal. Okay, whereas we have another frequency signal, so that is called as radio signal. Okay, so radio frequency signal. So this is called as radio frequency. Sometimes it is also known as, or it is also called as carrier signal. Okay, so carrier signal frequency that will be in the range of megahertz. Okay, for example, FM radio 93.5. Okay, cell phone signal 800 to 900 megahertz. TV signals 3000, 4000 megahertz. These are called as radio frequency signals. So as the frequency is high, therefore according to formula E equal to H nu, the energy will be high. Okay, so these are the signals which are going to have high energy, therefore they can travel. Okay, they can travel to a long distances. Okay, to longer distances. So these are the signals which can travel to longer distance, but we can't listen these signals because the frequency will be in the range of megahertz, and we can listen the frequency or we can listen the signals, okay, which are going to have the frequency in between 20 to 20 kilohertz. So this will be the frequency of this signal is megahertz, so we can't listen these signals. Okay, so that is called as radio frequency. So then moving to modulation means, okay, so modulation means it is a process of changing. So what we are going to change? So here I am going to represent a carrier wave. Okay, so this is nothing but a carrier wave. Okay, I am going to represent the carrier wave as y equal to a sin omega t plus 1. So this is nothing but one of the mathematical expression for carrier wave. So where small a is called as amplitude. Okay, and here omega is called as frequency, and this phi is called as phase. Okay, so modulation means I am going to define the modulation. So modulation means it is a process of changing the amplitude of the carrier wave. Okay, so that is called as amplitude modulation. If I change the frequency of the carrier wave, okay, with respect to audio signal, who is going to change? Okay, the audio signal voltage. Okay, the audio signal voltage is going to change the frequency. So modulation means it is a process of changing the amplitude of the carrier wave with respect to audio signal amplitude. That is called as amplitude modulation. Okay, so in case of frequency modulation, it is a process of changing the frequency of the carrier wave. The frequency of the carrier wave, okay, with respect to audio signal voltage, that is called as frequency modulation. Okay, so in case of phase modulation, it is a process of changing the phase of the carrier signal with respect to audio signal voltage. So that is called as phase modulation. So that is the definition of modulation. So modulation means it is a process of changing, okay, any one of the character. So that may be amplitude, frequency, phase of the carrier wave with respect to audio signal voltage. So that is known as modulation. Then moving to the second part of the question, that is what is the necessary. Okay, suppose, okay, there is no modulation. If there is no modulation, okay, if there is no modulation, so I am going to send my low frequency audio signal. Here signal means audio signal. So here audio signal is nothing but it is a song, it is a speech. So here I am going to make a class, okay, and this class should be listened by a person who is sitting at 100 kilometers away from my position, current position. So practically the person is not going to listen because my audio is low frequency signal. So low frequency means low energy. So because of low energy, it can't travel to a longer distance. So that's why we can't send these audio signals to a longer distances. So in that case, we are going to take the help of modulation. So if there is no modulation, even though you can transfer the signal to a longer distance by taking an antenna. Okay, so with the help of an antenna, you can send the signal, okay, to a longer distances. But here the practical problem is the height of the antenna. What should be the height of the antenna? So the height of the antenna is in the range of nearly lambda by 4, where lambda is the wavelength of audio signal. Okay, so in case of audio signal, so most commonly the audio signal, what we are going to sing a song or speech, so it will be in the range of nearly 165 Hz to, okay, around 300 Hz. So 300 Hz is nothing but the frequency of a voice for kids. Okay, so 165. So this is nothing but I think it is the frequency of a woman voice. Okay, so similarly for men, the frequency of men's voice is around 255 Hz. Okay, so whatever the frequency, if I convert this frequency into wavelength, then substitute these values. So the height of the antenna should be, or it may be in the nearly kilometers, nothing but 200, okay, 300 kilometers. Okay, if I substitute the audio signal frequency, first of all you have to convert the audio signal frequency into wavelength, then substitute that wavelength in this equation, then you will be getting the height of the antenna, that is in the range of nearly 200 to 300 kilometers. Okay, that will be in the range of kilometers. So practically it is not possible to construct an antenna, okay, whose height is in the range of kilometers. Okay, so that is one problem. Okay, so another one. So if there is no modulation, you can send audio signal into space by radiating. Okay, so by radiating the audio signal into space. Okay, by radiating the audio signal into space, okay, then you can send the signal if there is no modulation. But here also there is a problem. The problem is nothing but, okay, the radiation power. So the radiation power, it will be in the range of 1 by lambda square. Okay, so here for audio signals, the audio signals frequency is low. Okay, for audio signals the frequency is low, therefore the wavelength will be maximum. If a wavelength is maximum, the power will be low. Therefore, again it is not possible to send the audio signal by radiating into space because the audio signals are going to carry low power. Okay, so because of these two reasons we are going to take the help of the modulation. Okay, so modulation means it is a process of changing any one of the character of a carrier wave, that may be amplitude, frequency, phase, with respect to the audio signal voltage, that is called as modulation. And the need of modulation is height of the antenna. So the height of the antenna, if there is no modulation, the height of the antenna should be in the range of kilometers, so practically not possible. And it is not possible to radiate the audio signal into space, okay, because the radiation power carried by the audio signal is very low. Okay, so that's why we are in need of modulation. So that is the second question. Then third question. Third one, a circular coil of radius r having n turns, nothing but it has n number of wire windings, n turns, carries a current I. Okay, it is going to carry current I. What is its magnetic moment? What is its magnetic moment? So this is the next question. So here the coil that is in form of a circle. Okay, so this is nothing but a circular wire winding in which the number of turns are capital M. Okay, in which I amount of current is going to be flowing. So according to Biot-Savart law, when there is a flow of current through a circular wire winding, it is going to generate a magnetic field according to Biot-Savart law. Okay, so one of the parameter to estimate this magnetic field produced by the magnetic coil, nothing but the circular coil, so that is magnetic moment. So we have a direct formula, the magnetic moment. Okay, so magnetic moment, small m, so it is indicated as small m. So small m equal to number of wire windings, nothing but turns, the amount of current flowing through the circular wire winding, into the A. A is nothing but area. Okay, so if small r is nothing but the radius of the circular wire winding, okay, the area of this coil becomes equal to, as it is a circle, so pi r square. So m equals to capital N I pi r square. So this is nothing but the magnetic moment generated by a circular coil when I amount of current is going to be flowing through the coil. So this is question number 4. So presently it is question number 4. Define magnetic declination. Okay, as you know, our earth is nothing but, it is a solid sphere. Suppose if I take, so this is nothing but the earth. Okay, so this is nothing but earth. So here we have north pole and this is nothing but south pole. So here I am going to imagine a nothing but a plane, vertical plane, which is passing through north pole and south pole. So this, okay, line, okay, here I am going to take an imaginary plane which is passing through north and south. Okay, so this is called as the geometric. Okay, so this is called as the geometric. Here I am going to write. So this is called as the geometric north. Okay, but the magnetic field produced by the earth magnet, okay, so that will be in this direction. So this is nothing but north. Okay, so this is called as magnetic north. See, okay, so actually it is a line which is passing through the north and south pole of Earth. Okay, but the actual magnetic field will be in this direction. Okay, the magnetic field produced by Earth magnet, so that is in this direction. So the deviation between these two, the angle between these two, okay, the actual geometric north and the magnetic north of Earth, that is called as the magnetic declination. Okay, so you can see this image on the screen. So where the red color is going to indicate the geometric north pole, while the black color is going to indicate the magnetic north pole. The deviation between these two is called as magnetic declination. So that is question number 4. Then we have fifth question. So define. Fifth question, what is? Okay. So what is work function? Okay, what is work function? So this is from photoelectric effect. So if I take a metal, so metal is going to have more number of free electrons. So free electrons are nothing but the impact of nucleus on these electrons is going to be minimum. So there is no effect of the nucleus on these electrons. Therefore the electrons can move throughout the material or metal very freely. So that's why these are called as free electrons. Therefore a metal is going to have more number of free electrons. Okay, so it is going to have more number of free electrons. They can freely move throughout the volume of the metal, but they can't escape from, okay, the metal. Okay, they can't escape from the metal. Even though those are free, they can move within the metal freely, but they can't escape from the metal. Okay, so but according to photoelectric effect, when light is going to be instanting on the metal, for example if it is cesium, okay, alkali metal, so when light is going to be instanting on a cesium material or metal, so emission of electrons takes place. So when light is going to be instanting on the metal, emission of electrons takes place. So that is called as photoelectric effect. So it is a process of converting the light energy into electrical energy. So when light is going to be instanting on cesium, potassium like material, so emission of electrons takes place from the surface of the metal, that is called as photoelectric effect. So what is meant by work function? So here the electrons are very free, they can move within the material, okay, but they will not be having sufficient amount of energy to escape from the, okay, material. So in that case they require some amount of minimum energy. Okay, the electrons within the metal, they require some amount of minimum energy to escape from the surface of the metal. Okay, then only you are going to get a photoelectric effect. So that minimum amount of energy is called as work function. So work function is nothing but the amount of energy, minimum amount of energy required for the electrons to escape from the metal like cesium, potassium, that is called as work function. So in case of cesium, the work function value, it will be in the range of nearly 2.5, 2.14 electron. Whereas in case of, for example, say if it is iron, so here the work function for iron is around 4.2 something I think. So electron, nothing but large amount of energy is required to remove the electrons by using photoelectric effect from iron. So that's why this is not preferable for the photoelectric effect. Okay, only cesium, potassium, alkali metal, they can be preferred. So that is fifth question. So sixth question. A transformer converts 200 volts, so it is AC, into 2000 volts AC. Calculate the number of turns in secondary winding if the primary the primary winding has 10 turns. So it is a problem from transformer. Okay. So first of all we have to know what is meant by transformer. So transformer is nothing but it is a electrical device, okay, that can change the voltage level or current level from low to high or high to low. Okay. Suppose if it is a voltage, so it is a device that can change the voltage from low voltage level to high voltage level, okay, and vice versa, from high voltage to low voltage. Similarly, okay, you can define the transformer in terms of current also. So it is an electrical device that can change the current level from low voltage level to low current level to high current level, or high current level to low current level. Okay, keeping the power P input, P output should be constant. Okay, so it is electrical device. Transformer is nothing but it is electrical device which can change the voltage level from low to high or high to low, or okay, which can change the current from low to high, high to low level, okay, by keeping the power as constant. So that is going to be the transformer. Okay, so here I am going to draw the circuit symbol for the transformer. So this is nothing but primary wire winding which is going to have n number of n1 number of turns. Okay, this is nothing but the magnetic core. So this is nothing but secondary wire winding, so which is going to have n2 number of turns in secondary. So this is nothing but primary. Okay, so primary wire winding, and this is nothing but secondary wire winding. So input AC voltage is nothing but say V1. So secondary voltage is nothing but V2. So we have a direct relation. Okay, so that is nothing but N1 by N2 equals to V1 by V2 equals to I2 by I1. Okay, so this is a relation between number of turns and voltage and current in case of a transformer. Okay, so here you can see 200 input voltage 200 volts into 2000 volts. Therefore, the secondary voltage is 2000 volts. Calculate the number of turns in secondary. So we have to calculate N2 value. Okay, if the primary has 10 number of turns, so N1 equal to 10 number. Okay, so I am going to make the use of this formula. So N1 number of turns in primary, that is 10, divided by N2 number of turns in secondary. So we are going to find out that one, equals to V1. So input applied voltage is 200 divided by, so the voltage across the secondary is 2000. Okay, so 0 0, 2 by 10 is nothing but 1 by 10. Okay, so taking cross product, the N2 equals to, okay, and 10 into 10, that is nothing but 100 turns. Okay, so the secondary is going to have 100 number of turns. Moreover, you can see primary voltage is nothing but 200 volts, secondary voltage is nothing but 2000 volts. So it is a device that is going to increase the voltage level from low voltage to high voltage. So particularly this type of transformer is called as step up transformer. So this is question number 6. Then question number 7. Question number 7. So magnetic lines form continuous closed loops. Why? So, for example, in case of electricity, okay, nothing but electrostatistics. So we have positive polarity and it is nothing but negative polarity. So the lines of force, okay. So in case of electricity, the lines of force will be always from plus to minus. Okay, the lines of force will be always from plus to minus. Okay, the lines of force in electricity from minus to plus, it does not exist. So that is the case of electricity, nothing but electrostatistics. But whereas in case of magnetostatistics, so in case of magnetostatistics, this is nothing but north pole, this is nothing but south pole. Okay, so in case of magnetostatistics or magnetism, so the lines of force outside the material, okay, they will be from north to south. Okay, the lines of force will be from north to south. Okay, that is outside the material. But inside the material, these are the lines of force which will be south to north. Okay, so from north to south, again south to north. Therefore, the lines of force in case of magnetostatistics or magnetism, that is closed loops. Whereas in case of electricity, okay, the lines of force will be always from plus to minus. There is no line of force from minus to plus. Okay, so why magnetic lines form continuous closed loops? Why? Okay, so why means you can see in case of electricity. So you can get separate positive, separate negative. Okay, nothing but here monopole exists. Okay, in case of electricity, okay, monopole exists. If I add one extra electron to the atom, that becomes equal to negative. If I remove one electron from the outer shell, the atom will become positive. Okay, so in that way you can get monopole. Okay, but whereas in case of a magnet, so monopole does not exist. So this is nothing but a magnet. So north pole, south pole. Suppose if I want to get the north separate pole, so if I cut the magnet, automatically every piece is going to be acting as a magnet. So again it is going to have two poles. Okay, so here the reason is nothing but in magnetism, okay, monopole. So getting of separate north pole, separate south pole. Okay, so that does not exist. So this is the reason. Okay, so this is question number 7. Then we have question number 8. So microwaves are used in radars. So only microwaves are used in radars. Why? Okay, so basically radars are used to locate the position of say ships and aeroplanes or fighter jets. So that is the use of radars. So in case of radars, only microwaves are used to detect these objects. Okay, because okay, so microwaves they have high frequency or low wavelength. Okay, so low wavelength when comparing with radio waves. Okay, so in case of radio waves, the wavelength will be maximum. So here the microwaves are going to have low wavelength. So low wavelength means high frequency. Okay, they will be having high frequency. The microwaves will have high frequency. Okay, so because of high frequency, okay, the energy, this is nothing but frequency. Okay, energy will be high. So microwaves are going to have high energy, therefore they can travel to a longer distance without attenuation. Okay, so this is one reason. So microwaves, because of their high energy, they can travel to a longer distance. Moreover, you can get narrow, okay, narrow beam like a laser. Okay, you are going to get a pencil beam. Okay, so you are going to get a straight line of propagation. So that is called as narrow beam. So microwaves are going to have high energy. So because of high energy, they can travel to a longer distance without attenuation. Okay, that is one reason. And second reason is nothing but you can get narrow beam of microwave radiation. So in a particular direction you can focus. Okay, so this is nothing but the reason for using microwaves in radars. So that is question number 8. Then question number 9. So question number 9, state Heisenberg uncertainty principle. Okay, state Heisenberg uncertainty principle. So nothing but define uncertainty principle. Okay, so it is not possible. Okay, so not possible to estimate. Okay, it is not possible to estimate simultaneous measurement. Okay, so simultaneous measurement, or it is not possible to estimate. Okay, to conjugate. Okay, so to conjugate parameters or properties. Okay, like position. Okay, like position and momentum simultaneously. Okay, that means simultaneous measurement of position, momentum of an electron. Okay, it is not possible. Electron like particles. Okay, so simultaneous measurement of two particles, nothing but simultaneous measurement of two parameter, that is nothing but momentum and position of an electron, it is not possible. So here I will show you. So according to Bohr atomic model, electron is moving around the nucleus in circular orbit. Okay, so suppose if I say that the location of electron is here, that means you are defining the position. So position is known. Okay, so position is known because you are saying when electron is moving around the nucleus, in a circular orbit, this is nothing but the location of the position. This is nothing but the location of the electron. That means you are locating, you are defining the position of electron. So position is known. So when will you see an electron? So when light is going to be instanting on an electron, that will be reflected back. Okay, the reflection is going to form the image. Then only you can say this is the position of the electron. But when light is going to be instanting, okay, the electron will absorb some amount of energy. So when electron is absorbing some amount of energy, it is taking some amount of energy, its energy increases. If its energy increases, the velocity increases. If its velocity increases, the electron will be moving to another position. Okay, that means the momentum is going to be changing. Okay, so momentum is changing. So simultaneous measurement of position and momentum of an electron is not possible. Okay, so mathematically this can be represented as delta x into delta p equal to h by 2 pi. Okay, so another format or another definition, delta E into delta T equal to h by 2 pi. Okay, so in terms of angular motion, so angular momentum, delta J into delta T, simultaneous measurement of angular momentum and angular position. Okay, h by 2 pi. Okay, so this is nothing but the mathematical definition of Heisenberg principle. So according to Heisenberg principle, simultaneous measurement of both position and momentum of an electron is not possible. That is the definition. Then the last question, so 10th one. Draw the circuit symbols for NPN and PNP transistors. Okay, draw the circuit symbol for NPN and PNP transistor. So first of all, I am going to draw the transistor. So transistor is going to have 3 parts. One is called as emitter. So this is nothing but emitter. The second part is nothing but base. The bigger size is nothing but collector. That means all the 3 portions are not going to have equal thickness. Moreover, the doping concentration is also going to be different. So doping concentration for the three segments is not equal. So this is nothing but emitter, base and collector. Okay. Suppose if it is a NPN transistor, so emitter is made with N type, base is P type, collector is again N type. If it is a PNP transistor, emitter is made with P type, base is made with N type, and collector is made with P type. Then moving to the circuit symbol. So this is nothing but the question. Okay, draw the circuit symbol.